Welcome to this video presentation on how to name organic molecules, commonly referred to as using IUPAC nomenclature. IUPAC is an abbreviation that stands for the International Union of Pure and Applied Chemistry, and nomenclature means naming. So these are internationally recognized procedures throughout the world. At this point, you need to be familiar with the types of organic functional groups that are present in molecules. So make sure you are familiar with these before you proceed. Let's start by reviewing the 5 steps that are part of the IUPAC system. The first step is to identify the parent chain. This is the longest sequence of carbon atoms that are joined together in a line. The second step is to identify the type of carbon-carbon bonds and name them as a suffix. In other words, we're looking for a parent chain that represents either an alkane, alkene, or an alkyne. The third step is to identify branches in the molecule and name these as prefixes. These are the 5 common branches that we will encounter. The fourth step is to identify the functional group and name this as a suffix, and these are 4 of the functional groups. The last step is very important. You must give the functional group the lowest carbon number when numbering the parent chain. If not, otherwise give the branches the lowest carbon number possible. As we review these steps and going through a series of examples, they will be progressively harder. The best way to use this video presentation on naming is to pause at the end of each slide and practice the techniques that we've covered. As we go through the slides, they progressively get more and more difficult. Few students will be able to watch this video presentation in its entirety through once and actually understand all the steps involved. Naming organic molecules is a very elegant and straightforward process, but it does take practice to build the skills as you go. So do pause, practice, and then come back to this presentation at another time and review a few more of the steps, and you'll progressively get to more and more difficult organic molecules. Let's start by naming molecules that have branches in them. The first step is to identify the parent chain. This molecule has 2 carbon atoms joined together with a carbon-carbon single bond, so the basis of this molecule is ethane. We have a branch of a chlorine group on carbon 1. So this molecule would be called chloroethane. And this particular name, I do not need to write the number 1, as it doesn't matter which carbon I put the chlorine on, it will still be 1-chloroethane. So the 1 is not required in this name. This molecule has a parent chain that is 3 carbons long with carbon-carbon single bonds. So the basis of this molecule is propane. We have a chlorine group on the second carbon from the end, so this molecule is 2-chloropropane. Our next molecule has a parent chain of 4 carbons with carbon-carbon single bonds, so the basis of this molecule is butane. The NH2 is an amino group and it is on the second carbon from the end, so this molecule is 2-aminobutane. Our next molecule is again based on butane. We've got 2 branches now, both bromines, one on carbon 1 and one on carbon 2. So this molecule is called 1,2-dibromobutane. Notice that in this molecule we have 2 bromine groups, so we need a di in front of the bromo to indicate this. They are also 2 groups, so there must be 2 numbers in the name, 1 number for each bromine. And our next molecule, we have a parent chain that is 5 carbons long. There are 2 branches, a methyl group and a bromine group, and they are both on the second carbon from the end. So this molecule would be called 2-bromo-2-methylpentane. It is common practice with 2 different groups to put them in alphabetical order. B comes before M in the alphabet, so we'll put the bromo group ahead of the methyl group when we name it. Notice there are 2 groups, so there are 2 numbers, and the number must go with the group. When you look at this molecule, it's important to note that there are 2 ways that you may number the parent chain. In one way, you get 2-bromo-2-methyl. If you number the carbon chain from the other end, you get 4-bromo-4-methylpentane. That is not the lowest number system possible, so do check both directions to give you the lowest numbering. In our last molecule on this slide, we have a parent chain that is 6 carbons long. Be careful of this. Sometimes carbon chains can be drawn around corners, so it is helpful to draw a line through the longest carbon chain in order to identify it. So the parent chain in this molecule is based on hexane. That gives us two methyl groups, this one and this one. One methyl group is on the third carbon from the end and one methyl group is on the fourth carbon from the end. So this molecule is called 3,4-dimethylhexane. Again, two methyl branches, so we put a di in front of the methyl group. You should pause the video at this point and practice naming branch chain molecules using your notes and examples in your workbooks. In our second slide, we're going to look at carbon-carbon bonds. In this molecule, we have a parent chain which is 4 carbons long, so the name is based on bute. We have a carbon-carbon double bond, so this molecule is based on butene. We also need to incorporate a number for the position of the double bond, as there is more than one place you can put it. So this molecule will be called but1-ene. But for the parent chain, ene for the double bond, and a 1 to indicate the double bond is on the first carbon. Our second molecule is an isomer of but1-ene. It has a 4 carbon chain with a double bond on the second carbon, so this molecule would be but2-ene. Here we have a similar one. This is a 5 carbon parent chain with an alkene group on carbon 2, so this molecule is pent2-ene. In this example, we've got an alkyne with a 3 carbon parent chain, so this molecule is propyne. In this molecule, we don't need to put a 1 to indicate the position of the triple bond, as in this molecule there's only one place to put it. If I move the triple bond between the other 2 carbons, I still get propyne, just drawn from a different direction. It is tricky to know when to put a number and when not to put a number. If you put a number and it's not required, for example you write prop1-ine, you'll still be marked right, as that name is correct even though the number is not required. But like butene, which has 2 isomers, but1-ene and but2-ene, if you don't include the number, then you're not indicating which isomer is the correct one to draw, so you'll be marked wrong. It takes practice knowing when to put a number and when not to put a number, so if you're unsure, put a number. The last example on this slide is a 5 carbon parent chain with an alkyne group, so this molecule would be pent2-ine, indicating that the triple bond is on the second carbon along. The number is required in this case because there is at least one other isomer of pent2-ine, which is pent1-ine. Now let's look at putting carbon-carbon bonds and branches together. In this molecule, we've got a 4 carbon parent chain with a double bond on the second carbon, so this molecule is based on but2-ene. We have a bromine on carbon 1, so this molecule is 1-bromo-but2-ene. In this molecule, we've got a 3 carbon alkene with a bromine on carbon 1 and a chlorine on carbon 2, so this molecule is 1-bromo-2-chloropropene. Our next molecule has a 4 carbon alkane with a methyl group on carbon 2, a bromo group on carbon 1. So this molecule is 1-bromo-2-methyl-but2-ene. Now we have a 4 carbon parent chain with an alkane on position 2 and 2 bromine groups on the first carbon. So this molecule is 1,1-dibromo-but2-ene. Note that we've got the dibromo indicating there's 2 bromine groups, and we've got 2 numbers to indicate the positions of both of them. They're both on carbon 1. So make sure that you have it right. 2 branches, 2 numbers. And this molecule has a 4 carbon parent chain with an alkene group on carbon 2 and an amino group on carbon 1. So this molecule is 1-amino-but2-ene. Note the numbering sequence. It would be incorrect to name this molecule as 4-amino-but2-ene because that is not the lowest numbering system. Our last molecule on this slide is actually a 5 carbon parent chain. Note that the parent chain goes around the corner. So it's important that you check by drawing a line through the longest line of carbon atoms that are joined together in sequence. So this molecule is based on pentene with the alkene group on carbon 2. It has 2 chlorine groups, one on carbon 2 and one on carbon 3. So this molecule is 2,3-dichloro-pent2-ene. You should pause the video at this point and do some of the practice exercises in your books to practice naming branch chain molecules that have alkenes in them. Now we're going to move on to functional groups. So this molecule here is a 4-carbon alkane based on butane with an alcohol group on carbon 1. So this molecule is butane 1-ol. Our next molecule is an isomer of butane 1-ol with the alcohol group positioned on the second carbon from the end. So this molecule is butane 2-ol. Note, we don't call this molecule butane 3-ol because that's not the lowest possible numbering system. In our next molecule, we have this functional group, which is a carboxylic acid. This is a 3-carbon parent chain based on propane, where the carboxylic acid group is always on carbon 1. So this molecule would be called propanoic acid. With carboxylic acids, we don't put the 1 in to indicate the position of the carboxylic acid functional group, because it will always be on carbon 1, so we don't have to include it. This molecule here has an amide functional group, so it's a 3-carbon alkane, so it's propane with an amide functional group, so this is called propanamide. Our next molecule looks very simple. It's only got 1 carbonate, so it's based on meth. There are no carbon-carbon single bonds, but it is part of the alkane family, so it's methane. The functional group present in this molecule is this one here, which is an aldehyde. So this molecule is methanol. And our last molecule on this page has a 4-carbon backbone with carbon-carbon single bonds, so it's butane. This functional group is a ketone, so this molecule is called butanone. In this molecule, we don't need to indicate the presence of the carbonyl group with the number 2, as there is only one place to put it in this molecule and still have butanone. There are no isomers of this molecule, so the number is not required. Now let's combine functional groups and branches into the same molecule. This molecule has a 3-carbon backbone based on propane. We have a carboxylic acid functional group on carbon 1 and a chlorine group on carbon 2. So this molecule is 2-chloropropanoic acid. Our next molecule also has a propane parent chain with a carboxylic acid group on carbon 1 and a methyl group on carbon 2. So this molecule is 2-methyl-propanoic acid. This one has a 4-carbon parent chain based on butane, an alcohol group on carbon 1 and 2 chlorine groups on carbon 3. So this molecule is 3,3-dichlorobutane 1-ol. Again, a 4-carbon backbone based on butane with an alcohol group on carbon 1, a methyl group on carbon 2 and a bromine group on carbon 3. So this molecule is 3-bromo-2-methyl-butane 1-ol. Note, we put the bromo before the methyl in the name as B becomes before M in the alphabet. Our next molecule is based on propane with an alcohol group on carbon 1 and an amino group on carbon 3. So this molecule is 3-amino-propane 1-ol. Note that we give the number 1 to the functional group, which is the alcohol, and the amino group gets the carbon 3. So a similar molecule here, but this time we have a parent chain that is 4 carbons long based on butane, because our parent chain goes around the corner, with an alcohol group on carbon 1 and the amino group on carbon 3. So this molecule is 3-amino-butane 1-ol. Now let's look at some really challenging ones. These are the most difficult examples that I can give you, so don't panic if you can't do them. They are for extension opportunities. This first molecule here has 2 functional groups in it, a carboxylic acid group and an alcohol. Now the tricky thing here is we can't have 2 suffixes, ol and oic acid. So the way we handle this one is that we name the OH as a branch called hydroxy. So this molecule would be called 3-hydroxypropanoic acid. In our next molecule, we need to find the parent chain. And the trick is the parent chain must include the functional group or you can't name it. So the parent chain for this molecule is here. It is a 4-carbon butane chain with a aldehyde group on carbon 1 and 2 methyl groups on carbon 2. So this molecule is called 2,2-dimethyl-butanol. This molecule here also has two functional groups in it, and they're both the same. They're both alcohol groups. So how do we incorporate that? Again, we use the same thing we do for branches. We use the prefix di. So this molecule is ethane 1,2-diol. Our next molecule has a bit of everything in it. We've got a 4-carbon alkene chain, so it's butene, with an alcohol group on carbon 1 and a chlorine group on carbon 4. So this molecule would be 4-chloro-but-1-N-1-ol. Notice what we do here is that we remove the E of the butene and replace it with the ol. So the E drops off and the extra suffix is added on. In this molecule here, we've got a 4-carbon alkene with 2 alkene groups in it. So again, we use the di prefix. So this molecule is but-1,3-diene. And our last molecule has a bit of everything. Here we have a 5-carbon parent chain, again checking that they go around the corner, with the alkene group on carbon 2, an alcohol group on carbon 1, and 2 bromine branches on carbon 4. So this molecule would be 4,4-dibromo-pent-2-N-1-ol. As you can see, they can get quite complicated. Now you should try this one. It's a doozy. Pause the video, have a go, and see if you get the same as me. This molecule would be called 5-bromo-4-hydroxy-hex-2,4-dienoic acid. And well done, you've now worked your way all the way through the organic nomenclature system, covering all the level 2 and level 3 examples at the same time. So if you can handle these examples, you're doing really well. Remember, it takes practice. Make sure you can do simple examples. Simple examples get you achievement. The harder examples are for more capable students, but it takes practice, and with practice you should be able to do them all.